In this session we will solve one problem on flat face follower. So this is my problem statement. Follower type is flat face follower with the minimum radius of cam which is equals to the base circle radius is 30 millimeters. Angle of rise, that is outstroke angle theta O, is 120 degrees, and during outstroke angle follower moves with cycloidal motion. Outstroke is followed by dwell period of 60 degrees at the topmost position, which is followed by return stroke during which the cam rotates through 90 degrees. So return stroke angle theta r is 90, and during the return stroke the follower moves with cycloidal motion. The maximum lift of the follower, that is stroke s, is given as 50 millimeters, and the cam rotates in clockwise direction. So we have to find out the cam profile. So the first step is to draw the displacement diagram. In the displacement diagram, on y-axis we plot the stroke of follower, on x-axis we plot the cam rotation angle theta. So for y-axis, let us take scale of 1:1. Stroke length is 50 millimeters. So we plot distance equals to 50 on y-axis. Next we draw one horizontal line parallel to the x-axis through the point at 50 millimeters. So this is stroke length of 50 millimeters. So I can show it here, stroke length s. Next on x-axis we plot the cam rotation angle theta. The first stroke is outstroke, during which the cam rotates through 120 degrees. So for outstroke angle, let us take scale of 1 centimeter equals to 20 degrees. So 6 centimeter will give 120 degrees. So 6 centimeter gives 120 degrees. So this is my outstroke angle theta O. Taking 1 centimeter as 20 degrees. So 6 centimeter gives 120 degree of outstroke angle, which is followed by dwell period of 60 degrees. For dwell period, I have taken scale of 1 centimeter equals to 30 degrees. So 2 centimeter will give 60 degrees of dwell period. Dwell period is followed by return stroke angle of 90 degrees. For that, choose the scale of 1 centimeter equals to 15 degrees. So that 6 centimeter will give 90 degrees. So 6 to 12, 6 centimeters will give 90 degree. Considering the scale of 1 centimeter equals to 15 degrees. Now in the next step, we divide the outstroke angle and return stroke angle into even number of equal divisions. So I have divided the outstroke angle and return stroke angle into 6 equal divisions each. Okay. So this is 6 centimeters. So each division corresponds to 1 centimeters for outstroke. For return stroke, 6 centimeter represents 90 degrees. So each division of 1 centimeters. Now next we number these divisions starting from the origin. 0, 1, 2, 3, 4, 5, 6, 7, 8 up to, so this is 6 dwell period, 7, 8, 9, 10, 11 and 12. Now since the follower moves with cycloidal motion during outstroke as well as during return stroke, the radius of the generating circle is given by stroke length divided by 2 times pi. Stroke length is 50 divided by 2 pi. So radius of generating circle is 7.95. So we take distance equals to 7.95, approximately 8 millimeters. So this is 7.95 or 8 millimeters. On the extension of x-axis, I will draw this generating circle whose radius is 7.95. Now we divide this circle into same number of divisions as that of the outstroke angle and return stroke angle. So first of all, let us draw the ordinate or y-axis. Then we start the divisions from positive x direction. So 360 divided by 6, 60 degree each. So this is 60, this is 120. Let us mark these divisions on the generating circle. And from this side, so let us number these divisions. So this is 0, 1, 2, 3, 4, 5, and this is 6. Now in the next step, we project these divisions on the y-axis. So we project these division numbers on y-axis by drawing horizontal lines. So this point represent point 1 and 2, division number 1 and 2. This will represent division number 3 and 6. And this will represent division number 4 and 5. Now in the we will project this on this actual y-axis. So this is 4, 5. At origin will be 3, 6. And here is 1 and 2. Next we draw the diagonal for the outstroke. This line has carried with it point number 3 and 6, 3, 6. So this projection line will intersect the division line number 3 at 3 dash and 6 at 6 dash. Now we draw the line parallel to this diagonal line from the points on the ordinate. This line will carry with it point number 1 and 2. So this projection line will intersect the division line number 1 of the outstroke at 1 dash and division line number 2 at 2 dash. Next we draw a line through this ordinate 4, 5. This will intersect. This line is carrying point number 4 and 5 along with it. So it will intersect the division line number 4 at 4 dash and division line number 5 at 5 dash. In the next step, we draw a smooth freehand curve passing through all these intersecting points. So 1 dash, 2 dash, 3 dash, 4 dash, 5 dash and 6 dash. This is the displacement diagram of the follower during outstroke while it is moving with cycloidal motion. Now outstroke is followed by dwell period of 60 degrees. during which the follower displacement is 0 and the follower is at the topmost position. So the 0 displacement of the follower will be given by a straight line. We get this as 6 dash. Now during return stroke, the follower moves with the same type of motion, that is cycloidal, and we have divided the outstroke angle into same number of divisions as that of the return stroke angle. So we can directly project these intersecting points across the division lines of the return stroke angle by drawing a line parallel to the x-axis. So we will go reverse because the follower is returning. So this is 6 dash, 6 dash, next will be 7 dash. So this will intersect the division line number 7 at 7 dash. So 6, 7, 8. This will intersect at 8 dash, 9 dash, and this will intersect the division line number 11, 10, sorry, and this will intersect the division line number 11. So here is my 8 dash, this is 9 dash, this is 10 dash, 11 dash, and 12 dash will coincide with 12. Next we draw a smooth freehand curve passing through all these points in order to get the displacement diagram during return stroke. So this is the displacement diagram of the follower during outstroke and return stroke when it is moving with cycloidal motion. Now in the next step we will draw the cam profile. So the first step in drawing the cam profile is to draw the base circle. The radius of base circle is given as 30 millimeters. So we'll take a distance of 30 millimeters in compass and draw the base circle. So this is the base circle of the cam with radius of 30 millimeters. Now the follower is radial follower, so I will draw the follower along the vertical axis. So this is the flat face of the follower which is in contact with the cam profile at the lowermost position. We name the center of the cam as O and the trace point as 0. We join these 2 points, trace point and the cam center, because this is radial follower, and this will be the base to measure the angle of rotations of cam. Now the cam rotation is given as clockwise, so we will divide this base circle in counterclockwise sense. Now second step is draw the prime circle, but in this case, since the follower is flat face follower, trace point and point of contact in the lowermost position are same, so base circle will coincide with the prime circle. So we divide the prime circle or the base circle into same number of segments as done in the displacement diagram. You can see in the displacement diagram we have divided the x-axis into 3 segments: outstroke of 120 degrees, followed by dwell period of 60 degrees, followed by return stroke angle of 90 degrees. So we do the same with the base circle. So we'll divide the base circle into 3 segments, one of 120 degrees, next 60 degrees, and followed by 90 degrees. Now we have to divide the circle in the direction opposite to the direction of rotation of cam. Cam rotates in clockwise sense, so we will divide the circle in counterclockwise sense. So first angle is 120 degrees. We plot the angle in counterclockwise sense opposite to the direction of rotation of cam. So first angle is 120 degrees. So theta O 120. Next is 90 degrees. Sorry, 60 degrees. So it will be exactly on the vertical axis. So this is theta D, dwell period or dwell angle. Next is 90 degrees of return stroke. So this is theta R, return stroke of 90 degrees. We have divided the circle in counterclockwise sense because the cam rotates in clockwise sense. Now in the displacement diagram, we have divided the x-axis outstroke angle 120 degrees into 6 equal divisions, as well as the return stroke angle into 6 equal divisions. We will do the same in the cam profile diagram. So 120 divided by 6 is 20 degrees each. So 20, 40, 60, 80, 100 and 120. We'll mark these divisions on the base circle. We'll number these divisions starting from 0. This is 1, 2, 3, 4, 5 and this is 6. Now return stroke angle is 90 degrees. So 90 divided by 6 is 15. So each division of 15 degrees. 15, 30, 45, 60, 75 and 90. We'll mark these divisions on the prime circle or base circle in this case. We'll number these divisions. This is 6, end of 12, 7, 8, 9, 10, 11 and last one is 12. And this is the remaining dwell period at the lowermost position. Now since the follower is radial follower, line of action of the follower will pass through all these division numbers and the cam centers. So let us join this. These are the line of action of the follower at all these instances. because the follower is radial follower, we directly join these division numbers to the center of cam. Now these are the line of action of the follower at all these instances. The follower will reciprocate along these lines at all these particular instances, and on all these instances the displacement of the follower will be as shown in the displacement diagram. So let us plot those displacements. So at instance number 1 the displacement of follower is 1 to 1 dash, and that is equals to 2 millimeters. So we'll plot that corresponding displacement in cam profile diagram. So it is 2 millimeters to 1 dash. Next, at instance number 2 the displacement is 10 millimeters. So this is 2 to 2 dash. At instance number 3 the displacement will take the corresponding displacement and plot at instance number 3. So this is 3 dash. At instance number 4 is 4 to 4 dash. At instance number 5 5 to 5 dash, and at instance number 6 it will be 50 millimeters. And at this instance also it will be 50 millimeters, because there is zero displacement during the dwell period at the topmost position. So the displacement at the start and at the end of the dwell will be the same. Similarly, we plot the displacements at all the instances from 6 to 6 dash, 7 to 7 dash, 8 to 8 dash, 9 to 9 dash, 10 to 10 dash, 11 to 11 dash, and 12 to 12 dash, and all these corresponding line of action of the follower. Now after plotting the displacement of the follower at all the instances from the displacement diagram on the corresponding line of action of the followers, we draw line perpendicular to each of this line of stroke at the positions of trace point. That will be the position of this flat face of the follower. So let us do that. So at 1 dash we will draw a line perpendicular to 1 dash. Then at 2 dash note that the two adjacent lines must intersect each other, and both of them are of course perpendicular to the line of action at that particular instance. Next is at 3 dash. It must intersect the line passing through 2 dash. At 4 dash must intersect the line passing through 3 dash. Now 5 dash and 6 dash. Similarly, we draw the lines perpendicular to each of the line of action at the instances from 6 dash to 12 dash. After this, we draw a smooth freehand curve tangential to all these perpendiculars drawn to the line of action at all the instances. Remember that 6 dash to 6 dash will be perfect circular arc, since during this period there is zero displacement of the follower. This is the last dwell, which is also a circular arc. Yes. So this is the required cam profile for the flat faced follower. Thank you.